Now here's a problem. Does increasing the amount of calcium in our diet reduce the blood pressure? Examination of a large sample of people revealed the relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers, therefore, designed a randomized experiment, comparative experiment. Someone needs to learn how to spell here. The subjects in part of the experiments were 21 healthy black men. A randomly chosen group of 10 of the men received a calcium supplement for 12 weeks. The control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in systolic blood pressure for the subject after 12 weeks in millimeters of mercury. The increase appears as a negative response. Take group 1 to be the calcium group and group 2 to be the placebo group. Here are the data for the 10 men in group 1. That's the calcium group. And here's the 11 men in group 2, placebo group. Is there good evidence that the calcium decreases blood pressure in the entire population of healthy black men? All right. So we want to do a significance test here. One of the main things to look at is, are these two data points dependent on each other? Are they the same person? Are they similar people? What are they? Since these two are have no different relationship than these two, we'll use independent t-tests, two-sample t-tests. What we want to do is start out with the means. In our null hypothesis, we want both of the means in these groups to be exactly the same. So mean of group 1 is equal to the mean of group 2. And if you want, sometimes people like, instead of 1 and 2, they like to be a little bit more specific with their subscript and say the first mean is the mean of calcium, the second one is the mean of the placebo. In our alternative hypothesis, we wanted this to have a decrease in blood pressure, and this decrease corresponds with a positive number. So we want the calcium group to be more than just the placebo group. Now we have to define both these variables. Mu of C equals, now just to save myself some bad writing, this is the mean systolic blood pressure of black males that took the calcium. All right, now maybe I can reduce that size a little bit, make it 22. So now the other mean, make this 22. How about we just copy this? So if I bring this down here, it's the mean systolic blood pressure of the males who took the placebo. So now I have the mean of calcium, the mean of the placebo, and our hypotheses are complete. Now we have to check the conditions. Now it didn't say anything about these men being a random sample, so you could say something about these men are not a random sample for either group. Now we'd want to check normality. To check normality, what we'll have to do is graph them. Now I put these in, L1 and L2, and I graphed them both in two different plots, and I found the top one looks something like this. So it's a little longer. The bottom one is a little lower. Like that. And so what we can do is say both distributions are reasonably symmetric. So we can assume the sampling distribution is approximately normal distributions. Great. So now we have the normality. And for this one, we're kind of sampling with our replacement. So there's 10 and 11. And so for independence, maybe we can just say we can assume independence because there are more than, say, it's 11, so 110, and the other one was 10, so 110 covers them both. Black males. There's way more than that. So we can assume that each one would be independent. All right. So we have our second part done. We have our conditions. And now we move to calculations. All right. So we first start with our situation. We want to say we are doing a two-sample t-test. And we want to find out our means. So so here are the mean of the first data set and the standard deviation. This is the mean I got from the second data set and the standard deviation. So now we want to find do a t-test statistic. Usually with these, we just write t and equals, and then we subtract these values. So because the equation, here, let's look at the equation. So I just pulled the equation from the other page. So this is our model for doing it. So what we're going to do is we're going to take our first one, 5 minus a negative 0.27 repeating, all over the square root of the first standard deviation, 8.74 squared over n, which is 10, plus 5.9 squared over 11. Now if we do this all out, we can get a t-value. And this t-value is 1.6. So now we find a p-value based on this. And typically what people do is it's best to just use your calculator to find the t-value and your p-value from here, and using your two sample t-tests. And your p-value would give you a value of 0.0644. Now if you look on this, the degree of freedom, which is always good to note, is 15.59. They use a really complicated equation. I'll show you in a bit on how to get there. And but for what we're doing, the calculator gives us the best approximate of your p-value with this degree of freedom. So from here, what we want to do is we want to interpret. So I'll start typing. We fail to reject the null hypothesis because the p-value of 0.06 is above our alpha level of 0.05. And it's just barely above. It's really close. Now, once we have that statement, that is just statistical words, we need to have a conclusion. So if we did not conclude what we wanted to, that the calcium group is higher than the placebo group, that's what we state. We do not have evidence that the calcium group has a higher decrease in blood pressure than the placebo group. So our goal was to see that the calcium group had a higher decrease, but in the end we couldn't prove that to be true.